Okay, now we are on 4-7. And you know all these words right here. Coordinate, we talked about coordinates. Give me, what's the first thing pops in your mind when you think of coordinates? A point, right. A point. What do we call the thing where you got a parentheses and a comma? What do we call that thing? Yeah, it's a coordinate, but it's an ordered pair, okay? It's an ordered pair. All right, so that's kind of what we're going to do right here. Everybody ready now? Okay. So, and of triangles. So we're gonna graph triangles is basically what we're gonna do. Okay, and then we're gonna talk about some, I don't know, kind of interesting things about the triangles. So they start off right with an example. They don't even teach anything. They just say, here's an example. But they're gonna teach you through the example. What they're doing right here on the example, they're leading you up to something that we're gonna learn a little bit later in the day, okay, in the class period. So this isn't necessarily the lesson. It's leading you up, okay, to the lesson. All right, it's just making a foundation, creating a foundation for you. All right, and so the question says, find the slope and the length, and we're going to use this example 1 through the couple other examples. So this example 1 really is a big deal, so we want to make sure that we get this. Okay, it says find the slope, and we're going to graph this in just a second. Find the slope. Yeah, don't worry, we're not finished with slope, okay? So this is something we're going to use quite a bit. Find the slope and the length of each side of the triangle. The length of each side of the triangle. And you're thinking, what triangle? Well, they give you a triangle. So let's do this. Let's grab a little graph thingy here. What do we call that graph thingy? We got a couple names.
Cartesian plane.
Coordinate's fine. You could say coordinate plane or Cartesian plane. All right. So just happen to have one of those. Now, obviously, you're not going to draw all those little grid lines on here. So you're just going to draw the x-axis and the y-axis. But when you put the little marks, I still got people not listening. Jack, get your head up. Pay attention. So this thing right here, when you draw the graph, you're not going to put all these grid marks, but you're going to put little dashes here. Boom, boom, boom. Okay, try to keep them as even as possible. If it's possible to use a straight edge, maybe you carry a ruler, maybe you don't. Just take a piece of paper, fold it in half, maybe use your calculator or something like that. Something that's straight to connect them, all right? Try not to be too sloppy with this, but that's what we're doing here. So we are going to plot some points. We're going to plot a triangle ABC. So I'm going to actually write down what the coordinates are for A, B, and C, and we're going to plot them. So you do the same. So let's see. It's A is negative 7, 1, negative 7, 1. And then B is 1, negative 5. And if we connect these 3 points, we're going to get a triangle, right? 3 points makes a triangle. And then 7, 3. What? It's 8. A, B, and C. Yeah, but there's not 6 points, okay? There's 6 numbers, but there's 3 points, okay? So let's plot that. Are you doing this yourself? I'll tell you what, let's use pink, shows up a little bit better than red on the screen. So let's negative 7, 1. So let's do that. 1, 2, 3, 4, 5, 6, 7, 1 is right there. Okay, 1, negative 5. There's 1, negative 5. 1, 2, 3, 4, 5. Everybody should be doing this. I don't know what the joke is, but let's everybody do this. 1, 2, 3, 4, 5, 6, 7. 3. 1, 2, 3, right there. All right, so this is point A. This one down here is point B. And this one right here is point C. And we're going to make a triangle out of it, so what do you think we're going to do? Connect them, right? Right there. And then we're going to go from here to here. All right, and then we're going to go from here to here. All right, so we got a triangle. That's nice. But what do they say to do? They find the slope and the length of each side. Well, we've done that before, right? Let's do this. We could look at the triangle. We're going to look at the triangle in a minute, okay? But if you wanted to, you could just take the points that make up that triangle and then just find the slope right from the points, couldn't you?
Yeah.
All right. But we will want to see the triangle eventually, all right? So it's not like we don't need that triangle. I'm going to actually kind of scooch this over to there. Is that all right? Give myself some room here. All right, we're going to find the slope. So I'm going to make a little column. Let's do the slopes of all three of these sides. So I'll just do the way I did it in my notes. Let's do the slope of AB. All right, here's how I'm going to write it. I put M. Why do we keep talking? Just let me talk, okay? So this is the slope. I appreciate your enthusiasm, but when you're talking over me, it's very distracting. So let's find the slope of AB. All right, so here's AB, and we should be able to do this pretty easy. Remember, it's the change in y or the change in x. So you subtract the y's, put it on top, subtract the x's, put it on the bottom from A to B. So it's 1 minus 5, or 1 minus negative 5. Or you could go negative 5 minus 1. Either way is fine as long as you do the other one in the same direction. All right, so I went 1 minus negative 5, and then I'm going to go negative 7 minus 1. And what is that? That's 1 plus 5, which is 6. This is negative 8. And what is that? If we reduce it, it's negative 1/2. You sure about that? How about 3/4? Okay. Now, does it matter if the negative goes on the bottom or the top? Does not matter, okay? So it doesn't matter. It's 3/4. It's not a half. You look at it. I'm not going to sit and explain why that's 3/4. All right, let's do another side. Let's do, what's the next one I did? BC. We're doing all three of these, okay? So I just did AB first. Doesn't matter which one you do first, okay? I'm going to do these three sides. So this is the slope of AB. What's going on today? It's probably because you're all dressed down. Everybody's all crazy today. So watch. AB, that's the slope of AB. Now we're going to find the slope of this side of the triangle. So let's find the slope of BC. So the slope of BC. Let's do the same thing, but we're going to do it with B and C. So I'm going to go negative 5 minus 3, and I'm going to go 1 minus 7. What's that? That's negative 8 over negative 6. And what is that? That is positive what? 4 over 3. All right, so that's the slope of AB. This is the slope of BC. What's the other side then?
AC.
AC. So let's find the slope of AC. All right, so here's A and C. Let's do that. It's 1 minus 3. And then negative 7 minus 7. That's negative 2. That's negative 14. What does that reduce to? 1 over 7. Okay? So there you go. You found the slope of all three lines. You're like, well, why are they doing that? We already went through slope. Why are you doing slope again? Well, there's a good reason. All right? Again, they're going to use example 1 to teach you something later on in this lesson. All right? So let's keep these, off to the side or keep them in your notes. I circled them because we're going to use these. Okay, we're going to refer back to these slopes later on. Everybody with me? All right, so now let's do the length. Now, how do I find the length of this line? I use the what formula? No. Slope-intercept just tells you the equation of a line. It doesn't tell you how long the line is. We're finding the length. Yes, the distance, okay? Use the distance formula. If we're finding the length of something, we're finding out how long that side is. Okay, that's the distance, correct? We don't have a length formula. We have a distance formula. So that's what we're going to use. So we're going to use the distance formula for AB, for BC, and for AC. All right? So let's do that. Let me push this up just a little bit, have a little bit more room down here. So now what we're going to do is distance. All right? So I'll just put like a D. We could put a big D or a little d, doesn't matter. So D is for distance of what? We'll go in the same order. So let's find the distance of AB, or the length of AB. All right? Jack, if you could stop tapping the pencil. Thank you. It's off screen? Okay, I'll scooch it over. Is that better? Okay. All right, so let's find the distance of AB. Oh, you didn't see that other stuff either, did you? Well, I could do that. There you go. That helps. There we go. Now we got the other stuff. Should have told me before. I wasn't looking up at the screen. Oh man, that cuts off a lot of stuff. I didn't realize how closely cropped that was. Okay, sorry about that. I'll move it over in a little bit, but let's do the distance. All we need is these 3 points right here to find the distance of these. So let's do that. Are you trying it yourself? Whoops. That was a squiggly line. So here's the distance formula. Do you understand? It is. You understand what I'm doing here? I'm trying to find the length of AB. I'm trying to find the length of all 3 sides of the triangle. Okay. I gave you the coordinates, and now what we want to do is find out how long that side is, how long this side is, and how long this side is. That's what we're doing right now. Okay. Before, we just found the slope of it. Okay. And why did we find the slope of it? I don't know. Maybe we'll use it later on. Well, I kind of do know, right? We will. We're going to use it later on. All right. So just bear with me right now. We're just finding some stuff that we found in the past. We've been tested on, I think. Have you been tested on this stuff yet? At least had a quiz on it, right? All right, so let's find the distance. So how do I find the distance between A and B right here? What do I do here? I just subtract, well, I do the x's first. It doesn't matter. It doesn't matter because you're just adding them together. So it doesn't matter if you do the y's first or the x's first, right? Because you're just going to square them, then add them up. Shh. Why all these? Stop. Listen to me. I'm talking. We got laughing, we got talking, we got conversations. Let's stop and pay attention. So we subtract the x's from each other for A and B. So it's -7 minus 1. And then we subtract the y's from each other. And again, it doesn't matter what order we subtract them in because we're going to square them. Whoops. Because we're going to square them, and squaring them takes away whether it was negative or positive anyway. So let's do this. What's this going to be? -7 minus 1 is -8. Let's do this in our head. Square -8, what do we get? 64. Now don't forget this square root though. Okay? And then let's do this. 1 minus -5 is plus, so it's a 6, and 6 squared is 36. Let's do this in our head. Oops. Oh my goodness. Why do I keep doing that? 64 and 36 is what? It's 100. It's not 110. It's 100. Okay, yeah, you're right. So, how many times do I have to say it? I don't understand. Why don't you just get the idea? Does it not register that when I say it once to be quiet, then everybody settles down? Then 5 minutes later, 2 minutes later, it does it again. I mean the rest of the class, okay? I want you just to listen to me. If you have a question, you can ask a question, but don't have comments every single time I say something, all right? Let's just do this. 64 and 36 is 100, but it's under a square root. So what's the square root of 100? Now you can say something. What's the square root of 100? It's 10. So the length of AB is 10, all right? And if you wanted to put it there, you could. We're not going to do that just yet. So let's do the rest of them. So let's find the distance of BC. All right, put a big old square root. But now, finding slope and finding distance should be pretty quick and simple, shouldn't it? Especially after doing all these. So again, what do? You subtract the x's. It's B and C. So here, it's these 2 points right here. So subtract the x's. Again, it doesn't matter what order you subtract them. I'm just going to do the first one minus the second one. So I subtracted the x's, and let's see what we get. 1 minus 7 is -6. If you square a -6, you get 36. Okay, put a plus. And you could go 7 minus 1. It doesn't matter. You still get 36, right? -5 minus 3 is -8. You square -8, you get 64. Look at this. It's the same exact thing, isn't it? All right. So look, BC and AB are the same length. All right. So that is 10 as well. It's a square root of 100, but we did it in our head, and we just said the square root of 100 is 10. All right. And now we do, I know that pushed off the screen, but now we do what? AC. All right. And let's remember what my points are. So A and C. So it's -7 minus 7. All right. So let's put the square root here. Put the shell. What did I say? -7 minus 7? And then it's 1 minus 3. Is that right? AC. So what's -7 minus 7? It's -14. Now, I already did the work. I wouldn't know what -14 squared is off the top of my head, but it's 196. Okay? So this is negative 14, but when you square negative 14, you get 196, okay? Plus, and then 1 minus 3, that's easy. That's negative 2, and you square that, and you get a 4. And what is that? That's the square root of, what? 196 plus 4 is what? 200. No. So what do we do with this? Well, I mentioned this one time this year, okay, and I said we didn't have to really worry about it, but they do this. Okay, go ahead, Anthony.
Didn't you tell us that we could just write the square root of 200?
You could, all right, but I'm going to write it a different way because of what we're going to do a little bit later, okay? You're not really going to be able to see how it works if you put square root of 200. So I'm just going to teach you this really quick. You probably learned this Algebra 1, but I don't know if you remembered it. But what times what is 200? Well, there's a whole bunch of things, but 100 times 2, okay? Yeah, that's the best one to use because, everybody watch, if I use 100 times 2, we have a thing in Algebra 1 that said if these two things are being multiplied underneath that one big square root, I could break them down into their individual square roots. So I could write this as the square root of 100 times what? The square root, not 2, but the square root of 2. Okay, not just a 2, but the square root of 2. Do you remember that rule from Algebra 1? You didn't do square roots in Algebra 1?
Not much.
Oh, goodness, you should have. Okay, but anyway, there you go. That makes sense, though, right? Does that make sense? Yeah. So what is the square root of 100 now? What's the square root of? It's 10. I can't know. It's not a 2. Square root of 2 is not a 2. Yeah, you multiply it, but it's not a 2. This is not a 2. That's the square root of 2. Square root of 2 is like 1.4 something, okay? It's not the same as 2. It's just the square root of 2. Now, here are your lengths. One length is 10, the other is 10, and the other is 10 square root of 2, okay? Just know how to do what we did right here because you're going to see that this comes into play a little bit later, all right?
If I get the square root of 300, I do 10 squared 3.
Yes. Okay? All right, we good with that so far? All right, so now what they're going to do is they're going to, it's a lot. Okay, you got all that in your notes, right? It wasn't that big of a deal. I mean, look, you're just doing the same thing 3 times, right? If you know how to do it once, you can do it 3 times. It's not that big of a deal. But what we're going to do now is I'm going to introduce a word to you.
What was the final answer?
There's no real final, well, the final answer to this particular question is what's circled here. See everything that's circled? Okay. Actually, this. I circled it just to make a point, but that shouldn't be circled. Okay. Everything that's circled is your answer to example 1. But listen to me. What did I say earlier? This is not exactly what we're here to learn today. Okay. This is going to lead us to something else. Okay. So this isn't the end all, be all, end all, problem. This is just leading us to something else. I just want you to see these numbers, see these slopes, okay, and see these distances because we're going to compare it to something else, all right? And here's another step in what we're going to try to do here. Let me find a triangle. Yeah, I can use this triangle. That looks pretty good. Just trying to find one that kind of looks like the one in the book. All right, let's just make this a little bit bigger. And now I'm gonna teach you a definition. And you're thinking, all right, we just did all that stuff with the coordinates. How in the world does what we're gonna do right now have anything to do with what we just did? Well, you'll see. It'll all come together, I promise. What we're gonna do is this. We're gonna take this side right here. I could do this to any of the sides, but I'm just gonna take these 2 sides right here. This slanted one on the left, this slanted one on the right, and what I'm going to do is find the midpoint, all right? So, I don't know, where do you think the midpoint is? We're just guessing right here. Probably about right there. Does that look like the midpoint?
Yep.
About halfway of this. And then what we're going to do is take the midpoint of the other side right here. So where do you think that is? Maybe about right there?
Maybe.
Yeah, we're just eyeballing it.
Good enough.
We're just eyeballing it. But let me show you this. If I connect those 2 midpoints, we have a special name for that. Okay? So we actually have a special name for this segment. Let's name this. What did I didn't name it anything, but let's just name it ABC. For lack of imagination, we'll do that. Now, if this is the midpoint, And let's call this C and D. Oops, not C and D, but D and E. Okay? So watch this. What do I know about AD and DB? If this is the midpoint, this, they're equal to each other. Right, AD and DB are equal to each other because it's the midpoint, right? It's halfway. Everybody got it? Tell me something about AE and EC. They're equal to each other. So I'll put a little double tick mark here and here, okay? Now, we have a name for DE. So this DE, line segment DE, we call the mid segment. Okay? Kind of makes sense, doesn't it? Call it the mid segment because it's a segment, right? Starts at D, ends at E, and it's what? In the middle, right? Yeah. I connected the middle of this side and I connected the middle of this side, okay? This is the mid segment, all right? Now, with that said, I could, I'm not going to, but if this was CP geometry, I would probably go right to what the theorem says. But what we're going to do is we're going to discover the theorem, okay? I'm not going to prove it. I do actually have the proof of it in my notes, but I don't have enough time to do that today. But I just want to do an example to show you what the theorem says and why it's true. So let's take a look. What I'm going to do is take what we did on example 1. This is where example 1 comes into play. All right, so watch. I'm going to take this. Oops. Let's scooch that over a little bit so it doesn't. There we go. I just want to grab that. I'm going to copy it, and then I'm going to scooch it down and put it right there. Okay? So this is what we did earlier. It's still on the screen, right? Let me push it over just so I have some writing room. Let's push it over to about right there. Okay? Yeah. Yeah. All right. So what we're going to do is this. We're going to find, we just found slope, we found distance. Guess what else we're going to find now? Since we did mid-segment, we're going to find the what? The midpoint. And what I'm going to do is I'm going to find the midpoint of AC. So watch. I'm going to find the midpoint of AC and, tell you what, put a line segment over top of it, and BC. And this is what they tell you. This is actually example 2, all right? So this is actually example 2. It uses example 1 to figure something out. Now, this is really important. Now we're going to actually see how this thing right here relates to the mid-segment, okay? So what we're going to do is find the midpoint of AC. So what was A again? Somebody remind me so I don't have to go up there. What was A? What was the point of A? It was -7, what? 1?
-7, 1.
And B was 1, -5. And then C was 7, 3. Was that correct? Okay. All right. So those are my points. So what I'm going to do now is I'm going to find the midpoint. All right. I'll just put MP for midpoint. Okay. And we're going to find the midpoint of AC. See that? I just put AC kind of small down there. Finding the midpoint of AC. So let's do that. AC. How do I find a midpoint? Well, it's an ordered pair, isn't it? Yeah. Okay. I'm going to put a divide by 2, divide by 2. How do I find the midpoint of AC? What do I do with the x's? Do I subtract like I did for the slope? I add them on midpoint. Okay. So it's -7 plus 7. And it's what? 1 plus 3. All right. Let's see what we get. -7 plus 7 is 0. 0 divided by 2 is 0. 1 plus 3 is 4. Divided by 2 is 2. So what is the midpoint of AC? It's 0, 2, right there. Do you see that? Don't worry about it. Let's just concentrate on this. All right, so I'm going to do this in a different color. All right, so that's the midpoint. We'll call it D. Is that all right? We'll say D, point D is the midpoint of AC. What do you think we're going to do now? Remember, we just learned what a mid-segment was, right? So this is the midpoint of this side. I'm going to take this side right here and find the midpoint of BC. So watch. I'm going to find the midpoint of BC. So let's do that. Here's B and here's C. Let's find the midpoint. So I'm going to just put the shell of it right here. And what again is BC? So it's 1 plus 7, right? And then it's negative 5 plus 3. Negative 5 plus 3. And what do we get? We get 8 over 2, which is 4. We get negative 2 over 2, which is negative 1. All right. And then so let's plot the point. Let me put it back in yellow. All right, let's plot the point for negative 1. 1, 2, 3, 4, negative 1. Look at that. It lies right on that line, doesn't it?
Holy crap.
That's why it's nice to have these grids and stuff.
Wait, how did you get the negative one? I thought it was, isn't it negative 8?
It's negative 2. It's negative 2 over 2. Negative 2 over 2 is negative 1. We'll call this point E, all right? Now, we found the midpoint of two segments, so guess what I'm going to do? We just learned a definition of midsegments, so guess what I'm going to do with these two midpoints? I'm going to connect them. Boom, right. Oh, it's close enough. Okay? So what is DE? DE would be called my what?
Your line.
My midsegment, okay? We just finished talking about it, all right? Try to follow along with what we learned earlier, all right? So DE, it's connecting the two midpoints. We wrote a definition down for midsegment, right? Well, did we actually write it down? I didn't actually write it down, but we talked about it, okay? We said that that was the midsegment. All right, so all that to say this. I want us to compare a couple things. We already found the slope of AB, didn't we?
Yes.
So save me from scrolling up. What was the slope of AB? It was negative 3/4? Okay. So the slope of AB is negative 3/4. Now what I want you to do is I want you to find the slope of DE. What does it kind of look like, though? It looks like they're what?
Parallel.
It looks like they're parallel. So they should, if they're parallel, they should have the what? The same slope. Let's see if they actually do. All right? So let's find the slope of DE. All right? So the slope of DE. Oh, and what are our points? This is D, isn't it? Right there. And this is E right there. So let's find the slope between these 2 points right here. So what do? Subtract the y's. 2 minus negative 1. We subtract the x's. 0 minus 4. What do we get? 3 over negative 4. So check it out. So the slope of DE is negative 3/4. Look, they are exactly the same. So what do you think is possibly true about the midsegment and the other side, that it doesn't connect? They are parallel to each other, okay? Now, that's not necessarily a proof, okay, but it does kind of indicate that they probably are, okay? There is a proof in the book if you want to look. I did it last night thinking I might show it to you, but I don't think I'm going to today. I think we'll just say that this is good enough, all right? So I just showed you that this line and this line have the same slope, so they must be what? Parallel to each other. So that's kind of interesting, right? That the midsegment is parallel to the third side. What do I mean by the third side? The side that's not connected, right? The side that's not connected between the midsegment, okay? Now, there's something else that's interesting. What else did we do earlier? We found the slopes and then we found the distance, didn't we? Okay, so now let's do this. Let's find the length of DE. I'll put it right there, okay? Let's find the length of DE. So again, my points are 0, 2, and 4 negative. Let's scooch it over a little bit. 4 negative 1. This was D, this was E. All right, I'm going to scooch it up. I'll come back to the graph in a second, all right? Let's find the distance of DE. So distance of DE. The length. We're finding the length of the midsegment. And there is something that's going to be interesting, okay? I'm not just arbitrarily just finding the length of any side. This is actually, it's going to have a relationship. And you're going to see it. It's actually pretty interesting. So let's find the distance. So let's do it quick. This and this. Okay, so DE, what's the distance? I subtract the x's, right? So it's 0 minus 4. Then I subtract the y's, and it's 2 minus negative 1, correct? All right, and what is this? That's negative 4. What's negative 4 squared? 16. Plus, what's 2 minus negative 1? 3. 3 squared is 9. And so what is that? That's 25. What's the square root of 25? It's just plain old 5. Now, Do you remember? So let me put this in yellow. So the length of DE is what? 5. What was the length of AB? Look in your notes. We did it. It's 10, isn't it? You see AB? The length of AB is 10. So do you see a relationship between 10 and 5? That's right. The mid-segment, this is important, the mid-segment is exactly half of the third side. So it's two things. So the mid-segment is parallel to the third side, right? Because they have the same slope. And the mid-segment is what in length? It's half the length of the third side. So those are the two things that we know about the mid-segment. And that's actually a theorem. So we have a theorem that talks about the mid-segment.
If the mid-segment and another line are parallel, then the mid-segment
is half. That's it. Okay. Now I could do that with the other sides too. I could have connected this midpoint with this midpoint. Everybody see that? Yes? So I could have connected this one with this one, and this mid-segment right here would have been parallel to this, and this length would be exactly half of this length. I could have connected this midpoint to this midpoint. So this mid-segment would be parallel to this AC, and this mid-segment would also be half of AC. You see, you could do it with all three sides, because there's 3 mid-segments here. I only did one of them. Okay, but there are 3 of them here. All right? All right, so our final thing is basically our triangle. Let's write it like this. Triangle mid-segment theorem. Mid-segment. I'm just going to shorten it a whole lot from what they say in the book. You could write it down if you want. But the mid-segment is 2 things, okay? One, it's what? It's parallel to the what? To the third side, okay? When I say the third side, it means the side that's not being connected by the mid-segment. Does that make sense? So the other side, okay? It's parallel to the third side, and it's what? It's half the length of the third side of the third. Now, they don't write it exactly like this, but it's basically what it says, okay? That's basically what your theorem says, all right? You can look at it in the book. It's all written out, real fancy words and stuff, but that's really what it says, okay? That the mid-segment is parallel to the third side, and it's half the length of the third side. And they have another example, but they're basically, on the other example, I'll just tell you what they did. We kind of talked about it already. Okay, what they did was this. They said, if I connect like these two right here, right, the midpoint to the midpoint, then this is going to be parallel to this. It's going to have the same slope, and it's going to be half the length of this. They just went through the work, okay, and just did it. And then if I connect this one and this one, I think I was off a little bit right here, but anyway, then this right here, this side right here, and this side right here would be parallel, and this mid-segment right here would be half of the length of this. That's basically what that example is doing for you, example 3. If you want to go through it and try it yourself, you can. I'm sure nobody will, but if you wanted to, you could. So look at that. Perfect timing. So you had a homework assignment, correct, for this. Let me see what it was. It's 4-7. Yeah, it's 4-7A. I'm breaking this into 2 sections, okay? So it's there we go. It's 4-7A, and it's pages 196, 197, 196, 197, and you're doing 1 to 16. 1 to 16. That is your homework. Let's do tomorrow. Have it finished for tomorrow, okay?